Good morning. So our group worked with Dr. Bassil's lab, which is at the Tropical Research and Education Center, which is in Homestead, Florida. Next slide. So this is his team, Dr. Elias Bassil, and then his biologists, Matthew and Pam, and graduate students, Aline and Faye. And they did presentations with us all week showing us the fascinating research that they are doing in molecular plant physiology there at the Tropical Research and Education Center. And so they're an arm of IFAS, the Institute of Food and Agricultural Science. So I think early on in the week, we talked a little bit about the land grant colleges, so that they're part of that. And they do both research and extension, and the extension is their educational outreach. And they're looking at plant biology and abiotic factors that affect plant growth, and specifically peanut, avocados, tomato plants, and then also cold stress on vanilla orchids. And so our group of teachers, myself, Melissa, Andrew, and Donna, we all happen to teach a different subject area. And so we tried to make this applicable to each of our subject areas, and therefore our possible dates of implementation have to do with where the curriculum, prior knowledge, and what we would be teaching would be have front loaded for the students in order to make their experience with Dr. Bassil's lab the best experience possible and for them to get the most out of it. Next slide. So our lesson is mostly focused grades 9 through 12, but we'll give a few ideas more towards the end about how you could use this in another grade level. And our subject areas specifically that you could use this for, we chose chem, bio, and environmental science. Donna works with students on the autism spectrum, and so she teaches all core content classes. And so these fit all of the teachers within our group, but if you reach out to Dr. Bassil, he could give you, if you're in a different, teaching something different, then I'm sure he would help teachers with that wanted to work with his group. And so the time needed would be, if you're not talking about all the front loading of information that would be required, the lab and the lessons would span several weeks just for data collection purposes, and then you would need time for 2 classroom, either virtual or in-person visits from somebody representing the lab at the Tropical Research Station. So the learning goals, objectives, and the standards we put in are, well, I actually wrote this slide, so they're a little bit more specific to biology than any other subject. But depending on how you were using our lesson in your classroom, you could write different goals, objectives. And we put the nature of science standards in here because that's relevant to what we've been learning all week. But of course, there are many other subject area specific standards that would be applicable to our lessons. So Dr. Bassil's idea, next slide. Oh, let me back up a little bit. So prior knowledge for the students that everybody would need to know besides whatever subject area you were in and using this specifically for is a basic plant structure and function. And so biology, we teach that in our curriculum more towards the end of the year. Environmental science is taught to support biology, and theoretically our chemistry students would remember what they learned in biology, but that may be doing some review with them because, as you guys said in your previous presentations, students often forget stuff almost immediately. They should have a basic understanding of the properties of water, and then of course some organizational structure for plant systems. And then the material and resources are great because they're very basic resources that don't, they're cost effective, I guess is what I could say. Pots, soil, readily available. If salt was one of the factors, they specifically at Dr. Bassil's lab look at saltwater effects on different plants. And But if you were going to use other factors, then whatever you needed for your variable and your independent variable in specifically. But these are items that students may already have at home if we go back virtual and this is a requirement, or items that could easily be purchased by the teacher through a small grant or whatever budget you have with your school. Okay, next slide. So this is the outline of the activities we planned specifically around the lab and the lesson. Dr. Bassil's lab, they would like to either do a virtual visit or an in-person visit and actually speak about the research that they are doing, give the students some idea of the research that's been done, and then pose a question for the students to solve. Either, you know, we have this problem and we'd like for you to help us solve it. And then your groups, your student groups can work in teams and do the student research that they need to solve the scientific problem. And then Dr. Bassil's lab would be interested in setting up appointments with those student teams virtually again for them to report back what they might test and to help guide those students in some way towards, you know, students can either make their projects too simple or make their projects too elaborate. And so kind of narrowing the focus and helping them with that, which I think is a great opportunity. And then if there's any testing of samples or anything like that, then their lab and team can participate in that. So we would provide students with an experiment outline and a data sheet. And you know, as teachers, that you can go up or down with this. If you have higher level students, you may want them to create their own data sheets and prove to you that they know what data they should be collecting. But if you're working with a lower grade level or a lower level group within your school, then you may give them some guidance or the entire data sheet. And then at the end of their experiments, there would be a wrap-up visit from the lab, and the students could present their scientific results. So it would be more of a students presenting to the scientists what they, the results of their experiment and possible answers to the original question that the scientists posed to them. And so target vocabulary can be, like I said, there's some very basic information that they need to know for prior knowledge, but depending on how you would focus this, you can add in the vocabulary that's specific to your subject area. And then we thought for assessments or evaluations, bell ringers, exit slips, and checks for understanding as you're going through and teaching your lesson. And then, of course, for the summative assessment, a final lab report and the presentation to the scientists. What I have done with students in the past, pre-COVID, was we did poster presentations like you would in graduate school or for science fair, and then invite other science teachers from your own school to come and walk around and have the students, you know, defend their research and explain what they did and why they came up with this idea and all of that that has to do with good peer review and presenting your science. And in a current COVID situation, that may not necessarily be something that you can do, but hopefully later on we may have that opportunity. Okay, next slide. So possible uses at other grade levels. Elementary, so depending on the grade level in elementary, it may be just enough for students to know that plants uptake water and how that happens, and a very simple demonstration that the teacher does. And not have them specifically do the labs themselves. And then of course, all of the information front loaded. In middle school, you might give them a specific variable to each group, but then go ahead and allow them to perform the experiments themselves. And then of course, at the high school level, more inquiry based, encouraging them to think independently and to come up with the procedures themselves. Some of you may teach AP and IB, in which they have to, in their first year, do some, well, with IB specifically, do some labs. And then in their second year, they have to generate their own research. And the reason a partnership with a scientist in any program would be great for this is that these students may need access to equipment we don't have. Some of the equipment that we got to see over the course of this week was absolutely amazing. The microscopes that they have that most labs may not have, but definitely a regular school would not have. And of course, none of us have at home currently. So any sort of analysis tools, some things teachers have already in their labs, if you're measuring electrical conductivity or anything like that. With if you wanted to do something specifically with salt, which is more closely tied to the type of research that they're doing at the Tropical Research Station in this particular lab, then you would be measuring that. And we did talk a lot about grants, and then so Stephanie sent out that email earlier in the week while we've been involved in this, and there are some small teacher grants, like the Florida Science Teachers has the $500 grant where you could be thinking and writing those grants now to get the funding to buy some equipment if you choose to do this in your classroom throughout the school year. So those are just some suggestions from us. Next slide. I didn't realize we would be taking questions all at the end, so we put this in here, but this is the end of our presentation.